we're looking at basic literacy items in the computer and computer systems in general. There we go. So classifying them, using computer systems, different components, how we store, what kind of storage systems we have, and a little exploration into what's in the future. So your vocabulary, which you've gone over, I'm not going to go over each one of those with you. Of course, the computer is one of the most important inventions of the past century. Okay, we could probably debate that just a little bit. Probably the phone is in there somewhere with that. Used to, when we were learning about computers, we would make a list of things that don't use computers. You know, now, I mean, it's ridiculous. So we don't even talk about that. I mean, it's in every fabric, every part of society and life. It's everywhere. And with the smartphone, the computing is just, we're just using computers for everything, you know. So the brief history, we first developed back in the 40s and the 50s a military computer called the ENIAC. And, you know, it was gigantic. It used really what we called tube electronics, basic electronics that were analog in nature, and changed it so that we could use and store really basic levels of information or data on a real basic level. And come on, PowerPoint, you can do it. I just know you can. Little information about the ENIAC. See it in operation.
The Army, desperate for a device to help them win the war, reluctantly committed to the proposed cost of $500,000. Mockley and a brilliant graduate student
That's a lot of money.
Engineering,
Back then.
set to work constructing ENIAC, the electronic numerical integrator and computer. Many times larger than Colossus, nothing close to ENIAC had ever been conceived. Nearly 100 feet long and weighing 30 tons, it contained almost 70,000 resistors, 10,000 capacitors, 6,000 switches, and 18,000 delicate vacuum tubes.
Carry that in your pocket.
Vacuum tubes burn out just like light bulbs. In a machine that contained 18,000 vacuum tubes, at least one had to be replaced every few minutes.
18,000 vacuum tubes.
After 2 years of intense work, the team completed ENIAC, 3 months after the Japanese surrender. Although it wasn't finished in time to help win the war, ENIAC was a marvelous machine. It could perform up to 5,000 additions, 357 multiplications, and 38 divisions every second.
The interesting thing about the ENIAC was that it had a general purpose capability. It could be reconfigured to solve other problems. And there was never any problem finding work for the ENIAC to do. All the armed services clamored for time on the machine. Industrial customers and university researchers wanted it. So it was kept busy right into the 1950s.
By far the most complex machine of its time, ENIAC still lacked many of the qualities of a modern computer. Its memory was very primitive and could only only store a maximum of 20 10-digit decimal numbers.
20 10-digit numbers is all it could store.
Each time it was programmed, and couldn't make logical decisions based on its calculations. But ENIAC had proven that computers could be constructed. Just before the end of the Second World War, John von Neumann, an advisor to Eckert and Mauchly's ENIAC project, wrote a paper that was to greatly affect the next stage of computer design. Von Neumann possessed a photographic memory and was one of the principal scientists involved in the Manhattan Project.
Yeah, you know what that was? It's the big A
Von
bomb.
Neumann's paper delineated the structure of the modern computer. It was to have a processing unit, a controlling unit, memory, input, and output.
There you
But
go.
most importantly, in the evolution of computers, it would hold its programming internally in its memory.
Had never been done
Internally held
before.
programs give computers their power and versatility, because an internal program can modify what it does based on data or the results of computations. Von Neumann's paper proposed a machine that truly had a general-purpose capability.
In this paper, he described the attributes of a computer. How important
He's looking in that
logic
screen right there.
was. It needed to have a central processor where the calculations would be performed. It needed to have a memory where the programming data would be stored. It needed to have an output unit, an input unit of some sort. He laid out the logical plan, the map for a computer, and pointed the direction for the future.
The idea for storing programs internally was the last key to developing the true general-purpose computer. But whether it was von Neumann's idea has long been hotly debated. Eckert and Mauchly, who had worked with von Neumann, claimed they formulated internal programs as a natural part of their work building ENIAC, although they couldn't stop and incorporate the idea into the machine. However, Eckert and Mauchly weren't included as authors in the paper. They felt they had been betrayed.
Scandal.
Realizing the computer might find itself useful in the business world, Eckert and Mauchly formed their own computer company. They set to work on a machine they called the Universal Automatic Computer, UNIVAC. The UNIVAC, unlike previous one-of-a-kind machines built to solve scientific or military problems, could be programmed to serve many purposes. The UNIVAC was also the first computer to be mass-produced and sold commercially.
Usually in a basement.
The machine could be
Heavy
programmed
floor.
for a variety of data processing tasks, such as payroll, inventory, and billing. Compact magnetic tape drives stored data, and results were automatically printed. Still, very few people understood how useful a computer could be. That perception changed dramatically on election night 1952, when CBS used a UNIVAC to predict the outcome of the presidential race between Dwight Eisenhower and Adlai Stevenson. Opinion polls said the race was too close to call. The UNIVAC figured otherwise. Engineers fed the computer early results of selected eastern precincts well before polls closed in the western states. Experts thought it was a tight race, but the UNIVAC predicted a landslide victory for Eisenhower. Even CBS didn't believe what the computer was saying, and hesitated reporting the computer's results. But in the end, the UNIVAC was correct. The power and utility of the computer had been proven. After the success of UNIVAC, various companies began to see a future in computer development.
IBM began to realize that computers would become smaller and less expensive and easier to use, and that there would be a place in business for these machines, and that indeed these machines might eventually replace punch card technology, their bread and butter.
By the early 1960s, IBM dominated the large mainframe computer market. Business was becoming dependent on computers. The machines were getting smaller, thanks to the switch from tube technology to transistors. And a race to the moon was about to make the computer further still.
Okay. That gives you a little snapshot of the ENIAC, and get to see firsthand, its operation, what it looks like. There's a lot of really good videos out there on YouTube showing the ENIAC in operation, a lot of others, and so that was just one I snagged, pulled in. So anyway, so all the way back to the 40s and 50s, and then coming forward, the IBM was produced in 1981. The IBM PC produced it, moving away from the mainframe and getting into the consumer market. And the first one we had at the vocational school, IBM PC, it cost us about $6,000. Okay, and had big old floppy disk, about this big, 5 1/4 inch floppy disk that it used. And actually, the first one, though, I take that back. The first one actually used a cassette tape. Actually, an old cassette tape player. Well, I call it old, and it was new. And we plugged that in through the microphone port to the back of the computer, and if we wanted to store our program, we saved it, or document or whatever, we saved it on the cassette tape. Saved it in there. So, come a long way since then. So, basically, when you think of a computer device that receives data, your input, or a machine's input, a transducer out in the industry spits out data, zeros and ones, okay, the binary data, and then can process that data, somewhat make a decision about it, where it goes and how it uses it, stores the data, and then can produce a result. Okay, and that process is going on now, in super fast mode. You heard about what the first computer was like. 357 calculations a second, something like that. Whereas now, your computers you're by, like that one there, Kevin, what was its speed rating on it?
2.7 gigahertz.
Yeah, 2.7 gigahertz. Okay, so that means what's a giga? Those you go. Huh? Billion. Is that billion? Giga is a billion. Okay, so 2.7 billion cycles per second. Okay, so that's how fast it is collecting data and processing it through the arithmetic logic unit and storing it or outputting it. That's what it's doing, a second. Okay, hertz. Those of you that's not in electronics, what's a hertz? Those of you in electronics, you can't answer that. Anybody heard of that? You heard of hertz? Okay. Sometimes you see a light bulb or any kind of electrical appliance, it has it on there. 60 hertz. Okay. It was discovered by, or I wouldn't say invented, but discovered by a man named Mr. Hertz. And he wasn't the guy that invented the car rental facility or whatever, the car rental business. Okay? So it's a measure of cycles per second. Okay? So 60 hertz. So when you see your rating on your computer, that's what it means. So we have software, hardware, data, and people. Okay? Computer just sits in here at night. Nobody's here. It's just sitting there, not doing anything, as a rule, hopefully. They may be in here talking and doing stuff at night. We don't know. So wires and transistors and circuits, we call that hardware. And then the instructions are the software. And then the data is, your text and your numbers and your images and your video and all that. Okay? when we classify them, we have special purpose computers that are used to control something else. We've got gobs and gobs of that going on now in all of our products. Just heard the other day they've invented now a three-dimensional printing process that can embed some electronics into the product as it's printing it out. So circuitry and I guess some other transducers of some kind. General purpose computers, desktop, server, tablets, mainframes, supercomputers, embedded, portable players, calculators, mixers, and now your refrigerator, they announced, GE or Whirlpool or GE? No, GE announced last week. Did you see that? You can buy a new refrigerator, and it also makes coffee. Okay? Coffee. They have a Keurig coffee maker. Y'all have seen those. It uses the little K-cups. They actually have one of those built into where the ice maker is, the water dispenser thing, and you pull out a little deal and stick your K-cup in it, close it, stick it back in there. And because it takes it a long time to heat up, for some reason, it takes 4 minutes for it to make a cup of coffee. I don't know why. They're trying to keep the electrical use down or whatever. So they've invented an app so you can have it automatically, using your smartphone, tell the refrigerator to start the coffee maker, so that when you're ready to run out of the house, you can stick it in there and push the button, get your coffee, and go. Okay? I mean, Mr. Coffee, he came out and we had a timer on it. It would make a whole pot of coffee in the morning. I mean, that's really not really novel. I didn't have to have an app to do that. I just set it at night, click. But that was a little computer, wasn't it? Deet, deet, deet. Little digital computer. So it's just amazing, the stuff they put computers and marrying all the communications together. So we use them for all kinds of tasks. We take raw data and change it into information. Your basic components, remember, are a processor, memory, some kind of expansion card perhaps. Might have to have an extra sound card. Might have to have an extra video card. Most of that's built right in, of course, on your laptop and on desktop systems, which are, sales of those are like, nobody's buying those pretty much except business and industry, schools, seem to be buying them. Then a communication card, maybe a network card. So all the extra components will go in there in these expansion slots. So the main circuit board is the motherboard, we call it. Has all these children that are attached to it. Your graphics port or slot, the PC or PCI interface bus, okay, peripheral component interface bus, where your video cards and other things go. Then your connectors for storage devices, like your hard drive, your DVD, and then expansion slots for additional memory, and then a heat sink and CPU. Look at that heat sink on that thing. I mean, it's those little electrons are jumping around inside that CPU, 2.4 gigahertz. They're running back and forth in there. Okay, can't make up their mind which way to go. So it gets hot. It gets very hot. Okay. So the CPU, brains of the computer. It also has in it an arithmetic logic unit, performs all the computations. Then the control unit that coordinates it all. So you got a AL and then you got a CU. Okay, arithmetic logic, ALU, and then a control unit, a CU. All right. Oh, yeah. And it's just with ones and zeros. Your computer can only count to 1. Okay? It only counts to 1. 0 and 1 over and over. That's all it does. It uses the binary language, binary counting number system. It's just a box of switches, okay? Just a really complicated box of switches. And you operating it are learning to press the right switch at the right time. Okay? So it puts the data into instructions. So a single instruction would be a byte, okay, or made up of single bits, and then part of the bit would be a byte. Okay? So a byte is a single character. Memory, stored on the motherboard. It can be. It can also be stored on your external devices. Your random access memory, it's only available as long as the power is on. So therefore, when you have a power fluctuation, you're working on a document, you haven't saved it, then you lose whatever you have been working on if you haven't saved it. Data and information, program instructions are stored in the RAM. Your random access memory follows this instruction cycle. The memory, the control unit fetches the instruction, control unit decodes it, then the ALU does the execution on it, does all the math and logic operations, then the instruction is fed into memory. So it goes from memory, process, CL, or CU, ALU, and then back to memory. For every instruction, a processor repeats the set of 4 basic operations. So it goes from control unit, so C equals A times B. Then it goes to the instruction is then decoded by the control unit. Then the ALU processes it and then sends it into written memory. Then you have a memory in your computer called random read-only memory, and it's there permanently as long as the battery in your motherboard doesn't die. Okay? So the ROM stays there, and it's read-only, the BIOS ROM. It contains instructions for your computer, telling it how to start up, what's connected, how to behave, different types of storage, make a permanent copy of the data. You have to store it on a storage device. So the hard drive has become, we use it all the time on your laptops and in your desktops, but now the solid state, instead of a spinning disk, using just really banks of RAM chips that are energized, memory chips. So inside of a hard drive looks like this, just a disk, very highly polished, very flat disk, okay, metal disk, and it has a metal oxide coating on it, fibers, if you will, of metal, and there's a little tiny magnet head that flies over the top of it like a 40 microns away. This is spinning at almost 1800 RPMs, okay, 1800 times revolutions a minute, and the computer control unit sends a code for storage that's either +5 or -5 volts, and makes the metal fibers raise up or push down. And it does that spinning at that speed and knows exactly, keeps track of where every little data bit is stored. Okay? It's pretty amazing. But it's been around a long time. Long, long time. Okay? Old tape drives had the same concept. It was just on a tape. They had to spin this way and spin back this way. So they figured out they could put it on disk. Okay? This is IBM XT computer. computer hard disk. So, this one might be a 500 gigabyte drive, this size. Actually, they come a little smaller now. Then you got this old beast right here. All right, it's out of IBM XT back in the 80s. And yeah, we thought, oh my God, why are you getting a computer with 20 megabyte hard drive? Not gigabyte, 20 megabyte hard drive. That's what this is. And we thought, man, that's overkill. You're wasting your money. You never use all that space. Okay, and very noisy, So same concept though. A disk that spins with a metal oxide coating on it, and a little magnet or a little sensor out there that actually controls the fibers. Okay. Another storage device, old floppy drive, floppy disk. It's floppy. That's why they call it floppy disk. And then they come out with the smaller ones. Okay, 3.5 inch. And inside of it is a piece of acetate. That's the floppy disk. That's what the data would be stored on. Okay. And they work pretty good. They held up pretty good, Now we use USB drives, or we use the cloud to store our data in. Various forms of solid state, and I'm not going to get through to lesson 2. That's all right. I'll do it faster on Thursday. Exploring computers in your future. Okay? So, wireless and mobile devices, that's really not futuristic, but they're common now as our wired desktop machines. And where is it going to go from here? What's next? What's the next big thing? What do you all think? After the smartphone, where do we go now for computing? What's going to be? Anybody want to dream what it might be? Yeah, Google glasses. They've been trying to do that. They're real expensive. They're pretty annoying. I was around some people at a conference that had some of those on. It's pretty annoying. They're looking out here, and they actually can pick up your gesture, A lot of that. But it's a computer, just a different display. It's still a computer. So, new type of computer. It's just a different way to interface, But where are we going to go? What after a smartphone that is basically a really powerful computer in your pocket that I used to dream about when I was in 7th grade. Think about, man, it'd be great if you could look at stuff on some kind of device, anywhere. Huh? Yeah, that kind of got it started, Everything in Star Trek has come true, by the way, just about, except for the teleportation. We can't do that yet, but I hear they're working on it. Beam us up. Don't say never. Yeah, put you back together wrong. We kind of do it, in a way, with 3D printing, if you think about it, because I can take an object and I can scan it in 3D and turn it into a digital object, if it's plastic, and or whatever, and then process it somewhere else. I can send that information digitally, process it, and then build it. Not very fast, but still, I can make a copy of an object. It's just not the object, the original object. So, all right, I'll quit talking about that. So it's an electronic device that receives data, processes data, it produces information, and stores the data. Okay, it derives its power from its speed, which is the cycles per second. It's reliable. Oh my gosh, they've become so reliable. At first they were terrible. They were always breaking. They were always failing. But This case in point, all these computers in here, they're 7 years old. I have yet to have one die. None of these have died yet. And they're used quite a bit, you know. So they're a whole lot more reliable than they used to be. Of course, they're accurate. You'll learn that in particular in your CAD when you start doing your CAD work, how accurate they are. You know, locating points in space on your screen that are to the 16th place decimal accuracy. You know, I can't even tell you what that number is. Okay? And of course, being able to store things and being able to communicate. So, the different classifications, they all perform the same functions. Now, there are some things that are called a computer that may not be a computer and they're missing. Maybe they don't store stuff, but they kind of act like a computer. Okay? Input and output, and working inside of another machine, but they're not really storing much information or data. Remember, the motherboard, center of all the processing, has the basic controllers on it. The types of memory, we have RAM, that's temporary, volatile, and then read-only, that's non-volatile, it's permanent. Instructions for the computer's operations. The CPU is the brains of the computer. To maintain our permanent copy, we have to store it somewhere on some type of storage device. That can be a hard disk or a solid state storage. Or people are thinking it's pretty much permanent out on the cloud through the internet, storing it on somebody's server somewhere. It's backed up with 3 or 4 layers of backups. Okay, so it's essentially permanent. So, class is dismissed, and we'll see you on Thursday, and I'll hopefully get started quicker and go faster. Have a great day. Do your best, do what's right, and treat others like you want to be treated.